Cinema has spent decades drilling one single lie into our heads. Being gigantic is awesome. You stomp through downtown, tanks can't scratch you, and you are basically a living god. But forget the movies for a second. Let's look at reality. Imagine you wake up tomorrow morning, open your eyes, and realize you are 50 feet tall. Your house is gone. You are lying in your neighborhood, and the five-story buildings around you look like a cheap plastic Lego set. Here is the part nobody tells you. You wouldn't feel powerful. You would feel absolutely terrible. And within about 10 minutes, you would be dead. No military, no missiles, no Godzilla. You'd be taken out by something way more ruthless, middle school physics. Let's talk about why the universe would kill a giant using nothing but math. It all starts with your skeleton. Right now, your legs support your weight just fine. But strength and mass don't scale up at the same rate. Way back in the 1600s, Galileo Galilei figured out something called the square cube law. It's brutally simple. When you scale an object up, its strength increases with the square of its size, but its volume and weight increase with the cube. If you multiply your height by 10, the cross-section of your muscles and bones gets roughly 100 times stronger. That sounds amazing, right? Wrong. Because your total volume and weight just exploded by 1,000 times. You gained 100 times the strength, but 1,000 times the load. The math instantly breaks. At 50 feet tall, your body would weigh dozens of tons. Scientists who actually run these numbers estimate that your leg bones would need to be thicker than tree trunks just to keep from shattering under your own mass the exact second you tried to stand up. This is exactly why elephants have massive, vertical, pillar-like legs, while gazelles have thin, springy ones. It's not about style, it's survival engineering forced on them by gravity. At 50 feet, you would crush your own skeleton before taking a single step. But let's play along with the sci-fi fantasy. Let's say magic makes your bones indestructible. You stand up. Now your heart enters the chat, and it is terrified. Blood doesn't care how intimidating you look. It still has to travel from your chest all the way up to your brain, fighting gravity every inch of the way. In an average adult, that's a quick trip of about 1.5 feet. But at 50 feet tall, your brain is now sitting nearly 40 feet above your heart. That is the height of a 3-story building. Giraffes spent millions of years evolving massive hearts just to push blood up a 6-foot neck. A giraffe's blood pressure is double that of a human. Now scale that problem up to a 40-foot vertical climb. Your human heart was never built for this. It would either fail immediately, causing you to pass out from a lack of oxygen to the brain, or it would try to pump so hard that your blood vessels would literally rupture under the pressure. You would suffer a massive, catastrophic stroke within minutes. If that doesn't get you, your lungs will. Human lungs rely on diffusion, a passive process where oxygen molecules cross the thin tissue into your blood. This works perfectly at our scale because our lungs have a huge surface area, unfolded. It's about the size of a tennis court. But remember our old friend, the square cube law? As your body's volume explodes, the relative surface area of your lungs shrinks drastically. Your giant body now needs mountains of oxygen, but your lungs simply don't have enough surface area to absorb it. This is actually why insects stay small. They breathe through tiny tubes called tracheae. If an insect grew to the size of a dog, its breathing tubes couldn't pull in enough oxygen to support its mass. A giant insect doesn't fail because its armor is too heavy. It suffocates from the inside out. As a 50-foot human, you would suffer the exact same fate. You would be gasping for air in an atmosphere full of it. But the absolute cruelest part of this thought experiment is heat. Your body generates heat based on your volume, the amount of tissue you have. But you lose heat through your surface area, your skin. Mice lose heat so fast because they are tiny, which is why they have to eat constantly just to stay warm. Elephants have the opposite nightmare. They generate so much internal heat that they had to evolve giant ears packed with blood vessels to act as natural radiators. You don't have elephant ears. At 50 feet tall, your body would cook itself. You would produce heat thousands of times faster than your skin could ever release it into the air. Within minutes, your core temperature would skyrocket. Your internal proteins would literally begin to denature, like an egg frying in a pan. Your organs would shut down one by one purely from thermal stress. This is why you never see a 50-foot mammal in nature or the fossil record. Evolution didn't skip giants because it lacked imagination. It skipped them because physics strictly forbids them. The largest land animals to ever live, the sauropod dinosaurs, were built completely differently. They had air sacs in their bones to keep them light, a cooler reptile metabolism, and a horizontal layout to spread their weight across 4 pillars. A scaled-up human has none of these things. An ant can lift 50 times its weight, not because it has superpower muscles, but simply because it is small. Scale that ant up, and it collapses. Scale yourself up, and you don't crush cities. You crush yourself. So the next time Hollywood shows you a giant casually stepping over buildings, just smile and remember, Hollywood lies. The universe doesn't need an army or a superhero to stop a giant. It just uses basic math.